Lesson 1, Scale Statements and Scale Factor. So what a scale statement is it's a way of describing the proportion made between an original size of something and a scale of it, a model of it, something either bigger or smaller than it. So we use this idea of model over original, or we can think of it as the scale over the actual. That's what we're trying to think about. Okay, so the scale statement for the height of a building is 1 to 70. If a model of the building is 25 centimeters tall, how tall is the building? So we're going to say the model over the original. And now we're going to change this 1 to 70 to a fraction, and it's just 1 over 70 instead of 1 to 70. And now we're going to set up a proportion. So if the model of the building is 25 centimeters tall, how tall is the building? So because we're talking about the model size, the scale size, the 25 goes on the top. We are looking for the actual size, so x goes on the bottom. Is this a problem we know how to solve? Yes, it is. What's it called? Proportional reasoning. And how do we solve for it? Cross multiply and divide. So we're going to go 25 times 70 divided by 1. We'll get our x value, and we get 1,750 centimeters is the size of the building. Now, we don't often talk about buildings in centimeters, so it might be more useful to describe it in meters. So we would divide by 100. So 17.5 meters is a much more appropriate description of this building. Okay, the following is a scale diagram of a poster being printed for a school. The scale statement for the actual size of the poster will be 3 to 15. Measure the length of the scale diagram to find the actual length of the poster. So I want you to pause the video and measure in centimeters this shape on your page. So you should have gotten it to be 5 centimeters by 5 centimeters. So we're going to go model over original. Our scale statement is 3 to 15. This is our model size. We want to know the actual length of the poster. So we're going to put the 5 up here. Oops. Centimeters. X goes on the bottom. We can use proportional reasoning to solve. So 5 times 15 divided by 3 is going to equal x. So we know that the poster is going to actually be 25 centimeters. Okay, example 3. You're building a model of a building that is to have a scale statement of 1 to 50. The actual building is 15 meters. What's the size of the model in centimeters? So we have model over original. And I like to write it in words first, just so I remember what's what. So we have 1 over 50. The actual building is 15, so we're going to put 15 on the bottom, x on the top. We're going to use proportional reasoning. So 15 times 1 divided by 50 is x, and we get 0.3 meters is our answer. And again, now that we're talking about the model of something, talking about it in meters isn't so useful. Centimeters would be better, so we're going to times this by 100 to figure out that it is 30 centimeters long. You do not have to convert and change to a different unit unless it tells you to. So this question really does, so make sure you read that question all the way through. Okay, example 4. The scale factor of a model train is 1 over 8. The actual length of the train car is 10 meters. What is the model length in meters and in centimeters? So we're going to go model over original, and we know it's 1 over 8. So the actual length is 10, so that's our original size, so we're going to put that on the bottom, x on the top, cross multiply and divide. So we have 10 times 8 divided by 1, which is, I said that backwards, 10 times 1 divided by 8. There we go. I was like, this isn't right. Something's wrong. We should get 1.25, and our answer would be in meters because we started with meters here. To change it to centimeters, we'll times by 100, so it'd be 125 centimeters. Which is more reasonable? The centimeters. Is this an enlargement or a reduction? How do you know? So we know that this is a reduction. It went from a huge train to a model train. And the way that I can tell is when we have our fraction of model over original, if the top size is smaller than the bottom, then it's a reduction. If it was like this, 5 over 3, and the top is bigger, then it would be an enlargement. So that's a quick way to tell. Last example, the scale factor of a diagram of an insect is 3. The actual length of the insect is 4.5. Is this an enlargement or reduction, and what's the drawing size? So we'll start model over original. It only gives us the number 3. So we need to make that into a fraction. Whenever you do not have a denominator and there's no number, it's the same as saying it's over 1. So it's 3 over 1. First off, before we even answer the question, this is going to be an enlargement. And I know because the top is bigger than the bottom. And it makes sense. You take a small thing and we're drawing a picture of it, so we're going to make it bigger. Okay, so the actual length of the insect is 4.5 centimeters, so that's going to go on the bottom because that's the actual size of the bug. And now we're going to cross multiply and divide, so we have 4.5 times 3 divided by 1, and we get 13.5 centimeters is the size of the drawing. Thank you for coming to my TED Talk.